So we're live for absolutely no reason whatsoever tonight. I don't really think it's going to attract many people because I haven't actually told anyone about it. So all I'm doing today, in fact, I'll tweet about it. Let's see. Tweet. Live streaming now! Exclamation mark. Tweet. So I don't really expect many people to come along, but I am here. And the reason I'm doing a little stream, I'd sort of set up the stream I did yesterday for this evening, but I didn't get back from football until about an hour ago. So I wasn't really ready. And so I've decided to just do something else today. So today I'm going to be finalising the old crap clock. That's the original crap clock. I can't even talk. So that it can finally be sent out. There's no camera today because I've not been out the shower long and I'm not going to make myself look pretty. So you just get me talking, which we'll have to do. So there are some features on this board that I've ripped out of the original that no longer exist anymore. So originally around here, hopefully you can see my massive cursor. Around here there was in fact that's probably why there's a bridge. Is that why there's a bridge? Well, I'm probably bridging grounds or something there. Originally there was crumbs, what is it? I want to say LM386, but that's an op amp, isn't it? Or an audio amplifier. It is an LM35. So it was a temperature sensor that would sit just there. And I wanted this to have a temperature sensor. However, I've just decided the one that comes with the DS23. What is it? The DS3231. I've decided that is good enough. So we're going to leave it as that. Nobody needs accurate indoor temperature sensing from a clock, so they're just going to have to make do. So I've ripped that out. What else have I ripped out? I think something else. Let's have a little look at the schematic and see what we've got left. So this is the brain, is what I've called it here. Part of this stream is going to be adding some notation to the schematic because I feel it's a little lacking. And it definitely is, because if I want people to be able to use this and not have to continually ask me questions, then it's a good idea if I add some notes on this. So we're going to add some notes here and look at what may be taken out and what might stay in. So this is this 74HC595. So should we just copy that? And we'll just use the same text over here. So this is the 595 shift register. I control the rows. Oh, it doesn't need to be in caps, does it? I control the rows. That's fine. And then this is the TLC 5940. So let's copy and paste. Does that say this and then I? Oh no, it doesn't say anything. So this is TLC 5940. I control the columns. No. How do you spell columns? Oh dear. I mean, it's lucky that, I don't really write for the web or anything for a living. Column. That's right. Is it? Turns out it is. That doesn't look right. Oh well, we'll go with it. I control the columns. Okay. Now what's this? Oh, this is the charging circuit. Okay, I think this should come out really. So I've built it in so that it has access to a 3.7 volt battery, or a 4.21, a lithium ion battery. And the reason I did that was because the DS3231 requires a battery for sort of keeping the time, essentially. Where is it on this board? Over here? Yeah, so we've got it going out to, it says VBAT, voltage bat, I guess, or voltage source battery. And this goes to BAT, which is connected up here on BAT. And we charge it as well. Now, the board, to start with, was actually going to be run with a 3.7 volt battery. And I've sort of abandoned it, mainly because I think people tend to keep clocks plugged in all the time. So why do you need a portable, like, desk clock like this one is? And I think the answer is you don't need a desk clock. So let's just not sure what happened there. I think my internet froze for a second. It's a bit strange. Sorry about that. I don't know why that happened. Gary's here. Hello, Gary. It's not really a proper stream. This is just me doing some work and streaming it at the same time. Doing some work. It's not really work. It's just finalizing the crap clock, the original crap clock, so it can actually go out. So this is the Max 811 111 Max 8111 1811. I'm just going to check that. Let's click OK. Max 1811. Yeah, it was. It's a long time since I've used this chip. So he charges, I've given it a personality already. It charges the battery. However, it's an expensive chip. There are a lot cheaper ones out there. And so people can change it. These, all of the input and output lines are labeled. So you can just sort of delete that chip and throw another one in. I can't remember what it's called, but there is a really, really cheap sort of SOT 2331, so people can just definitely use that instead. The Max 1811 I liked, but it was the first charging chip I'd used, so it isn't particularly ideal. I mean, it is in the situations that I've used it in. However, it's expensive. So, oh god, this bit of the circuit. So I said earlier, and some of you won't have been here. In fact, probably none of you will have been here because there was nobody watching the stream. I said originally, let me just open this beer. I didn't say that originally. That's just what I'm doing right now. Yeah, I said originally that the clock had been designed to run off a battery. And it had, and it was going to have a sort of an on-off switch, and then it would turn itself off after like 30 seconds. So you'd press a button to see what the time was. And I sort of decided that's garbage. Like, no one's going to do that. And you might if you had it on your wrist, but as a desk clock, who's going to reach over and press the button? So this can definitely come out. Oh wait, no, hang on, let's go for... This should be a 0 voltage on-off switch, I think. So it's pointless, but it is currently in the schematic. So I'm going to leave it there. And people decide to take it out. This is the section. Let's, what is it? Rip. Do I type rip up GND? Yeah, that's it. So if I look around here, yeah, we've got it right here. So they take up this section here, and we've got a switch dedicated to it. So it's a little bit pointless on the crap clock. So there it is in all its glory. The first time you guys have seen it on this stream. Now, I'd like to be able to sort of give this out, but I don't want it to be too complex because, one, criticism, it can be quite harsh. So I'd like to sort of avoid that by saying, well, maybe you don't need this section, maybe you don't need this section. And these are how all the bits work. So in the schematic, I'm just going through and sort of writing all these. Like I mean, I don't even know why I separated these out. I don't know exactly what they're for, but these are the programming pins and power pins. So programming for, what is it, 11, 12, and 13. Pin 10, not really sure. It was for blanking the TLC 5940, but I don't use it. Done. Oh yeah. And oh yeah. Also the 5 volts and ground. Input. No, put. No, put. There we go. Oh, heaven's sakes. Done. Oh, we're going to have to change this a little bit. Hang on. So let's add in what? I might have to do a shift enter here. Let's see. Shift enter works. Okay. And there. That's better. Oh, Mike Swan. Good evening. Have we spoken before, Mike? Your name really rings a bell. Oh, Gary, what the devil was it? The 4081? That will be with you. I posted it this morning, so it should arrive tomorrow, I would have thought. Now down here we've got buttons. Oh, I know what those are. So let's just copy this. So the buttons on my crap clock, I've only got 2, and that goes through all of the settings for setting the clock for scrolling through the modes. So one is change mode, and one's change mode plus, one's change mode minus. And so it goes up and down through the modes. But when you get to the time change mode, then one button becomes increasing the time. And since you don't have to scroll through that many to get through sort of 23 and 59, then you don't need an awful lot. So we've just got the up and down. So you only go up when you're in the change setting, and then when you press the other button, it confirms the change. So you set the hours, the minutes, then you set the day, the month, and then the year. And then once you've done that, it sets the time on the DS3231. And Bob's your uncle, or Fanny's your auntie, as they say. And that is the end of it. It keeps that time as long as you have a battery connected. Now, is that still there? Yeah, it is, isn't it? Okay. So I added in a pad for an LDR. A long time ago, I did this this build of... It was a lazy Sunday, and it was a clock. One of these acrylic-cased clocks with a 7-segment display. LED, ran from a DC jack, and it ran off one of these STC micros, and it had so many features that I was quite jealous of. And that's the reason I made this clock, was because it I'd seen so many out there that did so much. So they had an LDR to change the brightness of the LEDs on there, and so I thought I'd put one in here too. I don't use it. They run at full brightness all the time because there's a bit of an issue with the TLC 5940 in that it won't PWM at a sort of full brightness, because then it bleeds into the other LEDs. I don't really know why that is. My hunch is that my 74HC595 isn't switching at the same time, so there's some crosstalk, unfortunately, and I've tried to fix it in programming for, I don't know, months, and I haven't been able to do it, so I've just given up. And if I run it at 700, which is no, it's about, if I run it about 900, about a quarter of its output, 1/4 of the PWM output, which is 4096, because it's one of these 12-bit resolution ones, then they're fine and they completely behave. So it's the breakdown voltage of the diode, I guess. I'm not entirely sure. In fact, I'm really not sure. That actually sounds like crap, but yeah, it doesn't particularly work. So I was going to use this LED, so because they were so bright at 4096, and it does run at that highest PWM value for a while, provided I'm not switching through the rows really, really quickly, like I have to do if I want to set the seconds on that last section. So light dependent, I don't know, that'll have to do. Resistor input, you can read it on analog, probably 0. Should we go and check? So LDR is there. Where does LDR go in? LDR is on PC3. So let's find out what PC3 is. AT Mega 328P -PU pin out. So there is our pin out. And so what was it? PC3? No, was it? Why would I have done that? Okay, so it's on analog input 3. I mean, that's fine. Oh, of course, because SDA and SCL are on input 0 and 1. Of course they are. Okay, so analog input 3. Let's just read it on. There we go. So what's next to label up? Oh God, these are our transistors. Now, I think I could probably sort things out with the transistors, honestly, because I'm not pulling them. That's probably it, isn't it? Oh, crap, I'm not going to change it now. Oh, look at this. Brian is streaming. Well, good luck to you, Brian. There's not going to be... I didn't organise this as an event, so there won't be many, if any, people here. In fact, as long as we've got the lovely Mike Swan and Gary Rivet, then that's fine. I'm happy with that. So yeah, because I'm not... these transistors... 2N3906, that is a PNP, isn't it? Let's have a little look, because I don't remember. It's PMP. So so I should be holding it low, really. Flip. Do the outputs on the 74HC595 really go low? Because they're sort of set low, but maybe they don't actually go low. Interesting. It's possible they don't really go low. Maybe it doesn't at all go low. Oh well, we'll name it. It doesn't really matter. I'm not here to actually completely redesign the circuit. I'm just going to mess about. Let's jump on Twitch quickly and have a look at Brian doing streaming. Oh, look, there he is. There he is. Streaming away. I've muted him so you can't tell. I mean, he's doing... Let's say hello. Let's see if you were... Oh, well. He's doing streaming as well, which means everyone will be there probably. Anyhow, let's change this. So these are our outputs for our 74HC595. So row drivers for the 74HC595. Okie doke. And next up. What the devil is this bit? Oh, right. Okay. So this is the over-the-top decoupling that's absolutely unnecessary. However, it's more necessary than not. No, that sounds stupid. What's unnecessary and then more necessary than not? Okay, it's better safe than sorry, really. And we've also got the USB bypass switch. It isn't a switch. It is a couple of pads on the board. In fact, I can show you. So they are over here on the reverse, or on the top of the board. So if you... Well, we don't need them anymore because I've sort of removed this. But it's possible to still use these sections here. So source voltage, ground, and 5 volts. I picked up these little boost boards, which were 3-pin. And they would slot into these holes. And so it would use the source voltage, boost it to 5 volts, and then kick it out into the circuit. This thing consumes like 20 milliamps. So these tiny little wires are completely fine. But if you wanted to just use USB voltage or 5 volts, so wherever you plug 5 volts in, up here, or in through the USB down here, which also goes into charging the battery, then you can just short these two together by just creating a solder bridge. So let's do that. So we've got, oh, it's a bit of a mix match, isn't it? Mix match. Pick and mix. Oh, is it maybe? Pick and mix. Decoupling and USB plus, I don't know, 5 volt bypass, I guess. And then we've got, oh, this one's easy. This is our DS3231. Oh, properties. Oh, there's no need to shortlist it, David. Dave, sorry. David. It's just me messing about. It's not, there's no real point to this stream, just that I'm doing it anyway, so I thought people might want to hang out for a bit while I have a Sadler's Hop Bomb beer. If you're interested, it's one of my favorites. It's like a hugely artificial type thing, but it's American Pale Ale brewed with Amarillo and Citra hops. A sweet malt base is lifted by a powerful hop character. It says craft brewed beer, but I don't really believe it. But it's very nice. Plus, Dave, there's only like 3 people here, including you, I think. So I'm not overly worried about a big audience or out. I did tweet about it, though, I guess. So we've got the DS3231. I keep the damn time, fool. So we don't need to be particularly polite in this. There is an alarm signal here. Active low. Am I even using that? I'm not entirely sure. Uh-oh, here we go. We've got the LEDs now. Plus, I'm only streaming for until about 10 past 10, I think. And then I'm sort of going to relax before I go to bed, I think. So it won't even be live afterwards. I don't think. I don't know how this one works, where you just click stream now. So we are the LEDs in row and column format. What else do we have in here? We've got, I can hear Brian in the background. Oh, I've not muted his thing. Let's just close it, because there we go. So yeah, we've got resistors on each column. Column, because we can use this, because we drive this row by row. So when I drive this display, I'm driving it with these PNP transistors here. And on the last bit, we're not using PNP transistors because the 74HC595 can handle the current. So we're driving one row at a time and figuring out which LEDs need to be on, and then the next one. So we set all of the 74HC595 pins up in one. So all of them off and then one on. And then we set the TLC5940 to sync current or not sync current. So it figures out which ones are on and off. And then it resets both of those chips and then draws the next line and draws the next line, which is why it's kind of slow. It isn't ideal, but if you want to roll your own little display, then you either use specialized chips or you just run for whatever you know, which is what I did, and use the TLC5940 and the sort of the ancient 74HC595 that we use. That is everything on there commented, so that's good. So let's have a little look at the board here. One thing I probably should sort of check is the comments on here. So let's do top only. We don't need to Ratsnest it. We won't bother with that. But we can see that we've got hours pointing here. That's fine. I mean, it's crap, but that is the point, really. I don't need it to look really great. We've got bigger hours sort of points over here. That's fine. We've got labels on most of these transistor things. Transistors, I mean resistors. Let's just bring standard in again. All right, so that's why we can't do that there. Is that on the bottom? It is. Okay, let's take top again. Because this value can come around and sit there in a similar way to that one. I don't need that 100 UF capacitor, so let's get rid of it. Where is that on my schematic? Shall we find it? If I click show, no. Show, and then, well, it should be displaying here. It's that one, isn't it? Oh, that's 10 UF. The reason I don't want it is because 100 UF is really hard to find in that package. There are 2 of them on the board. I'm just going to delete them. 10 UF and 100 nanofarad is fine. So it's gone from there. Where's the other one gone from? Up here, I think. Maybe. Let's undo one of them and then the other. So if we delete one of them and find out where that's gone from. I don't really see where it's gone from. We'll undo. I'm sure if I click show on that, it should show it to me in the blooming board. Oh, it's over there. Oh, I don't think you're meant to be 100 microfarad. Are you? That might be to do with the crystal. We've got a 33 picofarad there. Oh no, we've got a 33 picofarad there. I think that's 100 nanofarad. It is. I'm going to change it. In fact, that's fine. We'll just change them all to NF. No, that's NF already. That one, properties. I mean, if there's no high frequency noise, then I'm not overly worried, but you can't go wrong with sticking an extra 100 nanofarad on there. So I'm all right with that. We'll just leave them as that. That way they're less confusing. And they're all over the place a bit. Let's have a little look. So I want to rip up ground again. And get rid of the top view. No, just see the top view rather. So we've got bigger minutes, whatever. So that's actually seconds now, but that's okay. We've got smash that, and then we'll just let's delete that. People can do what they like with that. We don't need that there. We've got my little face guy there. I really need to get like a new logo or something because I just drew this just for kicks, really. So we've got 10K there, 10K there. That one isn't a vector. Oh, it is a vector. The ratio is different to this one, is it? Properties, 16. That's better. Pin 2. Again, the ratio is not right on that one. Oops. I don't... Oh, these are test points, aren't they? So I designed it with the ability to have a buzzer attached as well, but I never really used it. So we've got buzzer plus and minus down here. So I'll leave it. People can use it if they want to, but I'm not overly worried. These are incredibly hard to see. So let's change the ratio on these two to be 16. And these ones as well. So on the actual print, they don't look the best. But if I increase the width of them, maybe they will. Same with this one, really. Oops. I'm on delete rather than move. So that's going to be clear enough, isn't it? That goes there. Let's see what else we've got. Do you know what? I think I'm going to have to use the old spanner here and just change the text. Oh, actually, I don't know what that does. What was it? The ratio? 16. Yeah, there we go. So let's see what else we've got around here that needs changing. I'm sure there's going to be something. Yeah, there's another one. And that's another one. There's one. There's one. That's one. And that's one. God, pin 8 is a bit... There we go. Ratio 16, okay. There. There. Hello. That one says 2K. Where do you belong? Just there, I guess. Okay, I'm happy with the top side. Let's go with the bottom side. Yeah, those are too small again. Are they? Actually, they look fine. Do you know what? All of the ones on the bottom side look all right. I think I might have already been through and done these. That one's not. Neither are you. Okay, so some of them aren't. Okay, let's save that and bring back our normal view. All right, I'm fairly happy with that. So now I just need to sort of package up the code and also package this up. I think I'll do Gerbers and also just the Eagle file so people can use them if they want. And I guess I'll have to do a little video of how to program the damn thing. I don't really have a spare board though, that's the problem. One that hasn't already been... Oh, it doesn't matter. I'll just have to wipe the program that's on it. All right, well, I reckon that is enough for me today, for tonight. So if you join me, which would be a surprise because there shouldn't be too many people watching, then thank you very much. It was just so you can see some of the stuff I do when I'm on my own and not deciding to do a stream. Okay, I will speak to you all soon. Goodbye.